Hello, this is a tutorial showing how to use the three programs I designed that calculate the electrical properties of the gold nanoparticle networks that we are building in the lab. To begin, find the three programs. You should have two MATLAB zip files and one Java executable, which can be found with the link that was provided. So in the MATLAB original, it's a standalone collection of MATLAB functions that was originally used to perform the more complex analysis and calculations. However, as the program grew, it became cumbersome and unintuitive, which necessitated the creation of a set of programs with a graphical user interface to make it more user-friendly. And what came of this was the MATLAB GUI and the Java particle editor. So the particle editor program allows the user to build the networks as seen in the SEM images and define its basic properties. Afterward, once a network topology has been defined, it can then be exported to its sister program, the MATLAB GUI zip file. And here you can import the network you just designed and perform the necessary calculations. So now I will take you through a simple step-by-step instruction of building a network and calculating its resistive properties. We will be doing a very basic example and then be going back to explain some of the other functions and features available. To start, open up your MATLAB GUI zip, go into GUI editor, open particleeditor.m, and run the file. You'll be presented with a GUI that should look exactly like this, except that your graph section will be blank. Once open, minimize, then open the Java particle editor application. You will be presented with a screen that should look like this. By default, you are going to be in editor mode. When you left click, inside the screen, you added a gold nanoparticle to your network. If you left click next to it again, you'll see that you've added a second one, but this time these two are connected, which is indicated by the black lines. These black lines indicate how the electricity is going to be flowing through your network, and it's important for defining the topology of your gold particle networks. Once you are done building all of the particles, what you can do is toggle into selection mode by pressing the hotkey S, and select a node, which is shown by the green highlight, and by selecting F, you can define it as being a sourcing node, and then by selecting a different node, you can press G by defining it as a grounding node. Before you save your network, be sure that you have at least one sourcing and one grounding node. So now what we'll be doing is be building a network that we've seen in an SEM image. So in selection mode, we can select a node, then delete it by pressing the delete key and start over. We'll be looking at SEM image A and be building the network in between these two leads. By convention, the left lead is the sourcing lead and the right lead will be the grounding lead, which means that any nodes that are connected to them will be defined as the sourcing particles or the grounding particles, respectively. So back into the program and looking at the SEM image, we can start building the network exactly as we see it. Once this is done, by pressing S, you can toggle back into the selection mode and select the rightmost node connected to lead and press G to ground it, the two leftmost nodes, and press F to make them sourcing, and then you can then press save. I'm going to save this as a SEM A, and all files are saved as CSV files. So go back into your MATLAB GUI, press load model in the top left, find your program, open it, and you'll see that your graph now changes to exactly what you just built in the program, but this time it can be viewed in 3 dimensions. We'll be leaving all these variables at the default value of 1, and then you can press calculate resistance. The resistance of this network is 4.33 ohms. Now we'll be going back into the Java application to describe some of its other features and applications. This section will be a little bit longer as I explain the different features available in the Java particle editor. So I'm going to open up a new session, and what I'm going to do is if you hold down right or left click and drag, you can pan around the screen. You can also, using the mouse scroll wheel, you can zoom in and you can zoom out. If at any point you're wondering about other hotkeys or forgotten a hotkey, you can press the help page on this left-hand bar, or you can press the H key, which toggles the screen on and off. I will be beginning to explain everything by going down this list. So we have the delete key, which can delete selected nodes, which we've gone through in the previous part of this video. An important feature is the shift key, which can pin the ghost node to the closest spot depending on the assigned packing type. So if we go back into the program, I'm going to delete these two nodes, and currently our packing type is cubic. So what we can do is, if we go in editor, hold down the shift key, it locks the particles to the closest location according to the cubic coordinate system. So, and I'm going to delete these nodes, and I'm going to switch the packing type to BCC. And so if I hold shift key and add nodes, it adds nodes in the closest BCC coordinate location. The packing type is very similar to FCC, except on the third level of the FCC and BCC differ. So I'm going to go back to that, but we'll get to that later. And so I'm going to open up the shift click, which helps you select multiple nodes in the selection mode. So I'm going to create a quick system here. So I toggled into selection mode. If I click one node and shift click another one, and if let's say you wanted these two nodes connected, what you can do is press A to add a connection, or you can press D to delete a connection. So A and D are the two hotkeys associated with adding and removing connections between nodes. So back into the help page, what you can do is you can do the right click, which when you right click on a node in editor mode, you can assign it to a ground or a source to a node. So let's say you don't want to use the F or G hotkey. What also you can do is you can just right click and do it that way. And then you are all set. Next item is the D, which deletes all the edges connecting to the selected node, and if two nodes are selected, deletes only the edge between them. So we've used the second part, but taking the node that we have selected right now, if we select it, then press D, it deletes all of the edges connected to it. Similarly, if we press A, it adds a new node, or new edges, to all of its connecting particles. So, to fully express this, I'm going to switch into BCC and create a fully surrounded particle, select the center one, and then press D. It deletes the edge from all of its surrounding particles. However, if I press A, it reconnects them. So, going back into the next hotkey is we have the Z, the move down in layers and move up in layers. Layers is an important feature in the program because this is how you add depth to your program. So, what I'm going to do is I'm going to delete all of the particles currently on the screen. And in BCC, I'm going to create everything on the first layer. And then what I'm going to do is I'm going to hit this add layer button. Now I have a level 2. And then if I shift click, I can begin adding into the next layer. You can see that the layers are indicated on this left hand side. In the middle of the screen, you have your current layer, which is 2. Now as you add layers, you can see that they can go as far and as many as you need. and your current layer is indicated by the red highlight on this bar to the left. If you want to move down your current layer, you can use the Z and the X keys, or you can select these buttons up a layer or down a layer. Layers can only connect, particles in a layer can only connect to particles in adjacent layers. So a particle in level 1 cannot connect to a particle in level 3, only level 2. And similarly, a level 4 particle can only connect to level 3 and level 5. So another function that we have is hide edges. As you can see, it can get visually confusing and can impede progress, so you can do hide edges, and then you can toggle it again to show edges. Additionally, you can select the option have edges only on the selected node. So when you select a node, it shows all of its connecting edges. Blue lines indicate a connection to a node on a layer below, and green lines indicate a connection on a layer above. So if I move to layer level 1 and select a level 1 node, we can see that there's a green line connecting to its connection to the level 2 node. We can also remove layers, but we can only remove the uppermost layer. We cannot remove intermediate layers. So we're going to remove all the layers except layer 1, 2, and 3. So still in BCC, I'm going to change the current layer using X to change to level 3. And then changing into editor mode, I'm going to press Shift, click, and then you can see how I am pinned only to the BCC coordinate system. So BCC repeats itself on the third layer. Whereas if we were in FCC, so I'm going to delete this third layer, and shift click using FCC, we can see that now it automatically pins to an FCC location. And if we were to add a fourth layer, we can then see that the FCC repeats itself on the fourth layer. So this is a quick way to build packed systems. I will be explaining the particle editor for the MATLAB code. So for the GUI, there are very few functions that have been implemented, but have been created and implemented in the MATLAB original. Unfortunately, it's unintuitive, hard to use, and counterproductive in a lot of cases. So I will be implementing them slowly into the GUI format as the need arises. But for now, I will explain the different display options, source types, resistance models, resistance distributions, and our other calculation functions. So to begin, by default, it's going to be displaying a z-axis. And what that means is that it will color these nodes depending on its location in the z-axis. And we have options for average resistances, average voltage drop, and the voltage of the nodes. Those have not been implemented into GUI format, but are available in the original MATLAB program. For the source types, we have voltage and amps. Voltage and amps have been implemented and can be used and should be used depending on how the experiments are being conducted, especially with respect to nonlinear calculations. So an archaic tunneling function has been implemented in the old MATLAB code, but not yet into the GUI. Currently, we only do linear calculations. For the resistance distribution, the only available one is Gaussian. Gaussian has not been implemented, but has been created in the other program. And for the standard deviation, this is relevant only for Gaussian. Same thing with sensitivity. So we have the options to calculate the resistance, which is the main purpose of the program. And we have the calculate delta R, which given default values of a base resistance of 1 and a percent change to resistance. And for all linear systems, we found that delta R over R will always equal the change in resistance that you put here. But for nonlinear systems, you may be able to deviate from that value. Alright, that was a quick overview of what these three programs do. And any questions, comments, concerns, I'll be happy to put into written format if you think that'll be clear. And thank you for your time.